So let us begin with problem number 1, asked in the university examination long back 1984. If the top edge of the vertical circular sluice gate of 1 meter diameter is located at a depth of 5 meter below the free water surface, find the total pressure and the position of center of pressure. Very straightforward questions which was asked in the university examination. Now we'll see its solution to the problem. Top of the sluice gate is 5 meter below the free water surface. 5 meter below the free water surface. Its diameter is 1 meter. Its diameter is 1 meter. Okay. Y bar will be located at the center, so therefore Y bar will be equal to 5.5 meter. 5.5 meter because top is 5 meter and plus 0.5, so it is Y bar will be equal to 5.5 meter. Okay, area is pi d square upon 4, which is equal to pi into 1 square upon 4. That is area is 42. Area is pi by 4. So area is pi by 4. We will calculate later on. Now W is equal to 9810 Newton per meter cube. Okay, so P is equal to W into A into Y bar. W into A into Y bar. So that is equal to 9810 into pi into 1 square upon 4 into Y bar is 5.5 meter. So 5.5 meter. So that is P equal to 42.37 kilonewton. 37 kilonewton. Now we want to find out the position of the center of pressure. Position of center of pressure. Lamina is vertically immersed, so formula will be H bar is equal to Y bar plus Ig upon A Y bar. Okay, so H bar is equal to Y bar is 5.5. Moment of inertia about the central axis in case of circular section pi into 1/4 upon 64 whole divided by pi into 1 square upon 4 into 5.5. Okay, so 5.5 is Y bar, pi into 1/4 upon 64 is Ig, moment of inertia about the central axis, divided by A is pi into 1 square upon 4 into 5.5. So H bar is equal to 5.511 meter. This is the answer for the problem number 1. Now problem number 2. I'll read out the problem. A circular plate 2 meter in diameter is immersed in a liquid having specific gravity 0.8 in such way that the highest and the lowest points of the plates are 0.6 meter and 1.4 meter below the free surface. Find out the total pressure and the center of pressure. Here this is the case of inclined lamina because here the two elevations are given here, 0.6 and 1.4 meter. So let us have the solution here. So this is the free water surface. free liquid surface, sorry, it is free water surface, because specific gravity is here, 0.8 is given here. Specific gravity of this liquid is given as 0.8. 0.8 is given here. Okay, so here 0.6, one part is 0.6, plate is 0.6, and another one is 1.4 meter. Another end is, so 0.6 meter and 1.4 meter, and this is the plate. This is the inclination of the plate. Okay, so this angle is now theta with the plane of liquid surface theta. So first of all, we'll have to find out this theta. Somewhere it is projected somewhere here like this way. It will be like this way, plane of the water. Okay, so this is like this way. So this angle is again theta. So first of all, we'll have to find out theta, this angle of inclination theta. So sin theta is equal to 1.4 minus 0.6. What is the size of the plate? Size of the plate is 2 meter in diameter. So size of the plate is 2 meter in diameter. So this diameter is 2 meter. Okay, so hypotenuse is 2 meter. 2 meter. So it is 0.4. It is 0.4. If we take sine inverse, we'll get theta is equal to 23 degree 34 minutes and 41 seconds. Now determine the area, pi into 2 square upon 4. Area of the plate is A, like this way. So it is 3.14 meter square, because 2 square is 4 get cancelled, so it is 3.14. Okay, then y bar will be somewhere midpoint of this point. Y bar will be located at midpoint of this. So y bar is equal to 0.6 plus 1.4 upon 2. So that is equal to 1 meter. Okay, all the parameters we got. Okay, now here we have to take caution, that is specific gravity is here 0.8 is given. So not necessarily that free surface is always water. In some case of other branches, this may be another liquid. So it is like mechanical or chemical engineering, this liquid may be different. So their specific weight, specific gravity also different. So we have to take the specific weight of that liquid that is related to the specific gravity 0.8. So P is equal to WA y bar. So P is equal to 0.8 specific gravity into 9810 specific weight of water into 3.14 into 1. So this is total pressure will be 246.42.72 Newton. That is 24.642 kilonewton. Okay, then we will find out the Ig. First of all, we will find out Ig, pi into 2 to the power 4 upon 64. That is 0.7853 meter to the power 4 moment of inertia about the centroidal axis. Then we will go for center of pressure. We'll go for center of pressure. So H bar is equal to Y bar plus IG upon AY bar into sine square theta. This is the formula for inclined immersed lamina. So H bar is equal to 1 plus, or I'll put it as 1.0 plus 0.7853 Ig upon area is 3.14 into Y bar is 1 into sine square. What is the angle? Angle here is 23 degree 34 minute and 41 seconds. So we'll take, or 0.4. Sine square theta is 0.4. So 0.4. We'll take it as 0.4. So it is 0.4. So we'll take here 0.4. Okay. Then H bar is equal to 1.04 meter. Remember one thing, that H bar, that is depth of center of pressure, is always lie below the center of gravity. H bar is always below the G. Let us go for problem number 3. Here there are slightly extension of problem number 1. We have already solved the problem number 1. If the top edge of the vertical circular sluice gate of 1 meter diameter is located at a depth of 5 meter below the free water surface, find the total pressure and position of the center of the pressure. Okay, so this is the problem that we solved as first problem, and we got the solution to this problem like this way. So this is Y bar, we found out 5.5 meter, then area pi by 4, then P we found out as 42.37 kilonewton, and the center of pressure we found out as 5.511 meter. So P is 42.37 kilonewton we found out, and H bar is equal to 5.511 meter, and our Y bar was found out as 5.5 meter in this case. Now there is an extension for this particular problem in this situation. Now what is that extension? Let us say, so extension to the problem, sometimes the PSC may ask such type of problems in their main examination. So considering the above problem, also find the total pressure and the position of center of pressure at different depths of the same sluice gate when the top edge is located at 5.5 meter, 6.0 meter, 6.5 meter, 7.0 meter, 7.5, 8 meter, 8.5 meter, 9 meter, 9.5 meter and 10 meter, and comment upon the results about the depth of centroid of the immersed lamina and its corresponding depth of center of pressure. In short, they want the relationship between the depth of centroid and the depth of center of pressure and the total pressure, effect of total pressure when the depth is increased or when the depth is more. So let us solve. We already solved such type of problem. So first of all, it is 5.5 meter Y bar, we got it. A we got it as pi d square upon 4. Then W is equal to 9810 and P is equal to 42.37 kilonewton we found out. H bar is equal to Y bar plus Ig upon AY bar. So here what we have to do, every time this depth will go on change. So 5.5 meter, 6 meter, 6.5 meter, 7 meter, 7.5 meter, 10 meter and so on. So the Y bar value will change here. Y bar value will change here. A will remain same. A will remain same. W will remain same. So only thing, the Y bar will change here. Every time the Y bar will change here. So therefore P value will change. P1, P2, P3, P10. Okay. And because Y bar is changing, Ig is constant, A is constant, so Y bar is changing, so H bar is also changing here. Okay, so based on the different depths, we can compute the values by substituting the Y bar in this formula. P is equal to W into A Y bar, and H bar is equal to Y bar plus Ig upon A Y bar. So P1, sorry, Y1 bar, P1, H1 bar, Y2 bar, P2, H2 bar. So this way we can go on doing the calculations, and the calculation in a gist I'll show you it here. Area is constant here. See here, the area is constant here. Area is constant here. Then depth is changing every time. So 5, 5.5, 6, 6.5, and so on. 5, then 5.5, 9.0 here, and 10. So up to this point, the examiner asked up to this. Then I have elongated this problem. So up to 15 meter I took it as. So diameter upon 2 is 0.5 will remain same. So depth top edge is 5 meter plus 5.5. So it is Y bar is 5.5 here. Then P is equal to 42354.675. So P kilonewton is 42.355 kilonewton. Ig remains constant here. Ig remains constant here, and H bar is corresponding to Y bar is 5.511364. So like this way we calculated as the depth increases. Okay, pressure also increases. You find this pressure is also increases here. Pressure is also increases here. So as the depth increases, pressure is also increases here. Pressure is also increases here. H bar also increases here. Now, what is the effect of the difference between the center of pressure and the centroid and the Y bar? Means the difference between H bar and Y bar. What happens when the depth increases? As the depth goes on increases, the difference between the H bar and Y bar decreases here. Okay, so as the depth of lamina, immersed lamina increases, so the difference between the center of pressure and the Y bar, that is center of gravity position, so that gets reduces here. Okay, so as the depth of centroid of immersed lamina increases, hydrostatic pressure also increases. So here this depth is increasing and hydrostatic pressure is also increases. Hence the relation between the depth of depth of the immersed lamina and the hydrostatic pressure is directly proportional. This directly proportional to this. And as the depth of the centroidal immersed lamina increases, the difference between the depth of center of pressure and the depth of centroid decreases. Hence the relationship between the depth and the difference between the depth of center of pressure and the depth of centroid is of inverse proportion. You see the here values here, you can see once again. So this is increasing, this is also increasing, but this is decreasing. This is decreasing. This is gets decreasing. So this is the solution to this extended problem.